Hello, everyone. My name is Andrei Marinica. I am a core team developer at MultiversX. This is the second video in a series aimed at developers trying to build smart contracts and decentralized apps on MultiversX technology. And the topic of this video is a very, very important one. It's about testing, about how we test our smart contracts, how we make sure they work properly, how we make sure that they don't bring any surprises for us or our users. I have quite a lot to tell you because, as you can imagine, in the past few years, we've built a lot of tools for testing because we've needed them and our community has needed them, and this is an ever-changing field. So without further ado, let's get going. This is on the agenda. I want to start with a short introduction. My introduction is this: whenever you start building a smart contract, it's a great idea to think from the very first moment on testing, on continuous integration, and it's very good to have some automated processes that will help you keep the level of engineering prowess and of correctness high at all points. So for this reason, I have taken the smart contract that we've built in the previous video called Workshop, and I have put it on GitHub. Basically, I have put it on my personal GitHub just to show you how it's done and to be able to set up some continuous integration. And this is what it looks like on GitHub. So I've just committed it here. And normally what you want is to have a main branch that is protected, in which people can only push via pull requests. I know this might seem elementary for some of you, but yeah, not everybody knows that's the correct way to do it. And I have created a pull request. It's this one. This pull request is simply the one with the CI because I just wanted to prove the point, to show how this works. So the only file is the CI config. I will talk to you later about how you configure the CI. And what you get is a pull request to the main, and you get some checks. Now, they have already passed. Sometimes they take longer, sometimes they take shorter. And basically, these actions, they're called, they come automatically when you import our CI module, let's say our CI scripts. So you don't have to set them up manually. They're pretty standard for all smart contracts. So this is where we want to get to. So this is our target. It's our goal. We have now to populate these actions with meaningful tests. So let's get going with that. We will come back to this later. Right. So let's take a step back and think a bit what it means to test a smart contract. What is a smart contract and how do we test it? Well, a smart contract is a program that runs on the blockchain. So in order to test a smart contract, we have to recreate its environment, at least to some extent. And smart contracts are run during transactions. So in order to test them, we want at least one transaction in that sort of simulated or real blockchain environment. Oftentimes, we will need more than one transaction. And when we start chaining these transactions together, we get like a story. We call it a scenario. So it's either something that has truly happened on the blockchain. It's either something that is being executed right now on a blockchain, or it could be something that could in principle be executed on a blockchain or will be executed in the future on the blockchain. The point of these scenarios is that they have to obey the rules of the blockchain and they have to convincingly simulate, execution on the blockchain. And these scenarios are not necessarily tied to a specific technology. They are more like a framework of thinking about smart contract execution. And as you will see, we have this scenario model, this scenario abstraction implemented in several languages. The simplest one is in JSON, just because JSON is pretty universal and it's easy to run on different systems. It's one of the most technology agnostic things. But you can also write these scenarios directly in Rust. You can write them even in Go. I won't go into the Go implementation, but I will talk quite a lot about the Rust implementation too in this presentation. So to get you an idea of how a scenario looks like and what it does, I would like to show you a JSON scenario. Now don't get scared or by the syntax. The syntax is not so important. I want to show you what it does, how it works. So let's assume we have a blockchain or a blockchain simulation. And the first thing we need to do in order to send any transactions is to set up some accounts. Now, on a normal blockchain, you will already have an account, but in this simulation, you need to specify what accounts there are. We tell the simulation, well, we want this account. The address. This is the name of the address, so we don't work with hex. That can be a bit unwieldy. And then we say, sure, we want to deploy a smart contract. This will be the name of the new smart contract that we'll be deploying. And then what we can do is actually do our first transaction right here, which is a deploy transaction. The owner does it, or the account that we named owner. We give it the contract code. Now, the contract code is what we've built in the previous video. So as you can see, we're actually still in the smart contract crate, and we still have the output folder here. We've built it last time, so the WebAssembly is what we're interested in right now. And we can give it arguments to the constructor. We can give it a gas limit, and after it has executed, we can check stuff about the execution. For instance, we can check that it didn't return anything as expected, and we can check that the status is 0. We can also write 0 like this. It's equivalent. So after this, we have a contract deployed on our little blockchain simulation, and then we can query it. Smart contract queries are similar to transactions, but they are not executed on the blockchain. We are executing them when we query the blockchain. All right, and we can get results out. Here you see the result. And then this is an actual smart contract call. We are calling the smart contract to add some number here. And again, we test the same way. So you can see it already looks a bit like a test because we have these expects here. And at the end, we also are allowed to check that what accounts we have created, what they have in storage, maybe what balance they have in eGold, stuff like that. So this is very, very, very basic overview of the scenarios. If you want to get any deeper than that, we do have. Let me put it on screen. So we do have documentation on this. This is the scenario testing overview. You can see the specification for this format. And we'll be adding some more in the near future. Now, let's get back to our little project here. So we've seen until now how to think about a scenario, how to conceptualize it. Now, let's see it in action. How could we see a scenario in action? Well, the most straightforward way would be to run it on an actual blockchain. So let's do just that. How could we run a scenario on a blockchain, or how could we run anything on a blockchain? Well, as a developer, for instance, we could open up the web wallet and we could send some transactions there. That's one way, but it's not very convenient. It's not necessarily designed for developers. If we have a front end, maybe we could use the front end and send some transactions. But at this stage in the project, we do not have a front end. So the thing to do for a developer is actually to write a little program that interacts with a blockchain that sends the transactions. Now, we have tools like this in Python and TypeScript, and I think there's a few more from the community. But as smart contract developers, we are working in Rust. So we would like to have something in Rust to help us send some transactions and test our contracts. So with this being said, I will introduce the interactor. The interactors are such little programs that are supposed to help developers play around with their product. and maybe also perform maintenance in the long run. Stuff like upgrading smart contracts or doing certain transactions that you might not do every day or that you cannot do from the front end. So I hope they will find a lot of uses. Now let's have a look at how this interactor looks like. It has a little CLI here. This is not standard and a little bit of code. But yeah, let's do a transaction. So CD. Right, so CD into the interactor, and let's run a deploy. So first things, we want to deploy the smart contract, and takes a little bit of time to build, and then you will see the transactions going on. So first thing that the interactor did, it was to take out the first account that we've been using. So there's a few test wallets out there, like Alice, Bob, and so on. We're using Grace because it's not so used and we don't want people to interact with us right now. And the first thing the tool did was to take the wallet and like if we search here, yeah, it's this one. This is basically the test account that we are using to send out transactions. And we already see the first transaction here, this SC deploy, 32 seconds ago. Now, the transaction has already happened, but the interactor sometimes takes a little bit of time to query to make sure that the transaction went through. And if we click here, we see this is the deploy with the code and all that, and it went fine. And now that we did the deploy, let's do an add. So we add and the value, let's say, I don't know, 5. And now we've sent another transaction. Another very cool thing, you get the new address. The new address will be somewhere here in the logs. So let's pop out the new address and have a look at it. And this is a fresh contract, and we already see the first add transaction. It's this one. If you look at the hash, is the same. And it completed, but now the interactor has to make sure that it went on all right. Until this happens, a few words about the code. The code runs on a very similar platform as some of the tests that you will see later, and it has the scenarios at the core as a core principle in them. Okay, so this transaction went all right. Let's do another one. Let's have 2 to actually see that it properly adds numbers. Right. So this is how the code looks like. You can do all kinds of things with it. You will see more examples in a tutorial soon. These interactors are a bit experimental, so you might see glitches at this point in their development, but they have been proven to work. And they are getting more and more stable by the day. Already we see the second transaction here. It's add with the number. So this is 5 and this one. And now let's query. Let's see if the sum is what we want. And the sum is 8. It is actually 8. So that's nice. Right. Now, we did this 3 transactions and a query. The query is not a real transaction. It's just something we do off-chain. And now I want to show you something really cool. So I mentioned earlier that the interactor runs on this philosophy of scenarios, which makes it very natural for it to also save its state as a scenario. So we have here a file called interactor trace that we've configured to save. And this actually is an exact replay of everything that we did. And this also works as a test. So the first step, very similar to this, is setting up the accounts. And in this case, the account that we're setting up is the test account of Grace. This is the same address, but in hex. And you will see the same balance. For instance, if we go here to see the account, this one is like 118 eagled. So what we have here, it's 118 eagled with 18 zeros. So that's cool. And also all the ESDTs that this account has. This is designed so that whatever you do with this account, when you want to replay it, everything will happen exactly the same. So you want the entire state of this account. Then the deploy that we did with the code and the same arguments and so on. And then the call, one with 5 and one with 3. And even the query, which gives us 8, which is also something that we can check, that we can test in integration test. So this interactor trace, this is actually a valid test and a valid replay of what we did. And you will see it run as a test very, very soon. Now, moving on. We did talk a little bit about JSON tests and how they look like, but now let's see how we can call them, how we can use them as tests, right? So we have a folder here with scenarios, and now I'm going to go in this in here, and I want to talk to you about how we execute these scenarios. So we have basically two systems that are both able to execute them. One of them is based on our VM. Our VM is written in Go, and it has a module for executing scenarios. We also use these kind of scenarios for testing the VM itself, but you can also use it to test your contracts. And now, normally what you want to do is to install it using mxpy, but we already have it installed, so I won't get into this video. It's called Run Scenarios. This is the VM tool. And I can give it the path, and we'll just run all the scenarios in it. So you can see it ran this scenario, and it passed. And if we want to take this interactor trace from here and put it in scenarios, we can, and it will also run the interactor trace, and it will run OK. So there we go. This is the old tool, the VM tool. And this is actually the only tool right now that we have that will also simulate gas consumption for you. The other tool is written in Rust, and we'll get to it in a moment. That one is not as straightforward to call. Right. So now let's see. But you might ask yourself, right? This tool is a standalone tool. How can I integrate it into my tests? So what we have is, so if you have this list of scenarios that you already have in JSON, you can make Rust tests out of it. And this file right here, it doesn't contain really any useful code. Most of it is auto-generated. This one you can auto-generate completely because it's just some boilerplate to get you to have these scenario files into actual Rust tests. This one is basically sets you up, so it does the same thing as what I've done earlier. It just calls this run scenarios tool. But we also have another one that it is in Rust written. This is basically the debugger. So this will help you have tests that you can also debug. These tests, the ones in Go, you cannot debug because we do not have access to the internal workings of the VM. And the VM doesn't have access to the high-level Rust code. It only has access to the WebAssembly code. But here something different happens. Here we can register a contract. This means we tell the framework, whenever you see this, whenever you see this path, don't try to open up this path. Don't try to load the WebAssembly. Just do this instead. Just load the smart contract instead. And what this will happen will be that if we run this test, you will not just blindly execute everything. You will actually be able to put breakpoints in your code. For instance, let's try to put a breakpoint here. This is the constructor, really simple stuff. And here in the test, we hit debug. We have to wait a little bit because it has to compile test. And as you can see, we hit the breakpoint in the smart contract. So with this, you can actually investigate your values. For instance, and we even have a tool for telling you what the values are. So we actually have a full debugging system that will tell you what the values are. You can investigate values, find bugs, and so forth. And if you continue, it will just finish. And yeah. So this is the debugger. It's a very useful tool, and we've just seen it in action with these JSON smart contracts. So even though we've written the scenario in JSON, we still have the debugger, and we can put breakpoints in the contracts. Okay, now, it can be a bit tedious to maintain these files by hand. In this example, in the initial version of the smart contract, we only had one scenario, so it was easy enough to set up. But you might have like dozens, you have hundreds of these scenario tests in some of the contracts. So we actually have a handy tool that I want to show to you to actually help you build these scenarios. So assume I just ran the interactor and I want to add this new scenario to the test suite. And there's this command called scmeta testgen. Remember scmeta from last time? And look what it did. It just added more tests for the new scenario that we added. And if I like rename this, I can also do this, and voila, it will also rename the tests. And we can run them. You will see in a moment what happens. So this is basically what I would call the scenario JSON tests. So tests based on the JSON specification of a scenario of what should happen. Now, but of course, writing these scenarios by hand is tedious. We don't always run the interactor when writing tests. So we want to also be able to easily write tests in Rust directly. And to write Rust tests directly, there's three flavors of tests. I call them the black box testing, the white box testing, and the unit testing. I will start with the black box tests because I think they are the closest to the real thing, to the interactor. They basically just mimic what you would do on the blockchain, but in a simulated environment. So very conveniently, this project that we have here has all kinds of tests. We have everything here. And now we're going to be looking at this black box test right here. Now, same as before, when we were running the JSON test with a Rust backend, we have to register the contract. So the initialization of the system will be the same. But now instead of just calling the JSON, calling the JSON logic, we actually have code, proper useful code. And what you see here is syntax very similar to what we have in JSON. So if you put them side by side, they look very similar. Just, of course, this is in Rust. The same way we initialize some accounts, like the owner with nonce1 and so on. And then we do some transactions, a deploy, a query, and so forth. This does the same as the JSON does. Just it's expanded nicely in Rust. But in truth, this is not really the way that anybody writes Rust tests. The problem is right here. Because we've taken the model from JSON, the functions and the argument are expressed in the same way, like strings or like expressions. And we don't like that. We're Rust programmers. We like types. We want to be able to call a function with, and then have the compiler type check us. And this is why what we normally do looks like this. So this is, again, it's almost the same system. It looks almost the same. Again, the set state is the same. The difference comes right here. So instead of doing function and argument, like here, we actually call a function called add on an object that we call adder contract with a real argument that is a number, this time not a string, and it is type checked. Now, what is this adder contract object? Do you remember from the last video we were talking about proxies? So proxies were used to help smart contracts call one another in a type-safe way. And this is nothing else than another proxy. This is just the same proxy. It's it works in the same way. It gives us a contract call that then becomes a transaction, and then we can execute. Mind you, this is not the actual add function in the contract, and this is not the actual constructor in the contract. This is a generated object that has the same public functions and as whatever that we declared as like endpoint or init or view and so on. And it gets generated in such a way that you have safe type checking all around. And this adder contract is initialized here. So, and it's for convenience, it also gives you can also give it a contract path and it handles everything. Right. So this is one very cool feature that we have that allows us to write proper tests in proper Rust. The other very cool feature I want to show you is this one. So this is a tracing system. It's the same, a very similar system to what we had at the interactor. So if you remember, we ran the interactor and the transactions that we did were saved in a trace. We do the same thing with the black box test. This is like the record button. We press the button, and then at the end, we save what was recorded in a scenario JSON. And in this example, we've put it directly in the scenarios folder, which is here. And now it has come to this, that we want to actually execute a test. Because until now, we did not execute any test, any Rust test at least. So I'll go like this. We just type cargo test to run the Rust test. This is very standard stuff. This is the same instruction that you would use for any Rust project, so nothing blockchain specific. This is, remember, these are pure Rust crates. We were writing pure Rust in them. So we're just using the regular tooling that Rust gives us. And we've run all the tests. They all passed. But beside the test passing, one of them also created this file, and we can see it here. It got generated, and here we have it in the scenarios. And once again, like with the interactor, if we come here, we can write sc meta test gen, and it got added to the test suite. So now we have the black box test here and here. Now, to be fair, this test, let's put this up. This test and this test, they really do the same thing. So because, this JSON file was generated from this test, they do the same thing. But, so you might argue, then what's the use of, generating a scenario if we're going to execute it the same way? Well, the thing is, this scenario actually can be executed also on the Go backend. And as I mentioned earlier, the Rust backend right now does not support gas, so it does not measure gas. And after all, it tries to replicate the VM as closely as it can, but it's not perfect. So you probably will get, in some edge cases, a bit of a more realistic execution if you run it on the Go backend itself. And that's very useful, actually. And the only way to run your Rust test on the Go backend is to generate a trace like this and then run the trace on the Go backend. And now you can test your gas, for instance. All right? So this was the black box test. Now let's talk about the white box testing. You can intuit maybe what it means. So the black box, on the black box test, we are treating the smart contract like a black box. We don't know anything about what's inside. The only thing that we have access to is what the proxy gives us, and the proxy only gives us the public functions. So the black box test only sees in a contract what the blockchain would see, so only the public functionality. But sometimes we might write integration tests that go a bit deeper, that peek a bit under the hood, and that call functions that are not public. So in that case, we did the white box testing. And I will show you the white box testing in a moment. So this is the white box test. Now, we used to have a bit older framework in Rust that was all white box, so that had no black box capabilities. We've adapted it and we've integrated it, and now it's a single system. So they're not actually different kinds of tests. You can mix white box transactions with black box transactions. But this test will be just white box. Again, it's exactly the same intro, we set it up the same way. We had to register the contract the same way because it's the same Rust backend. But now have a look here. The deploy would be a whitebox deploy. And again, we do want to specify the step. This is like information like from where, maybe the code. But then the call itself, if you look right here, is no longer a proxy call. It's actually a Lambda. And this SC that you see here is the actual smart contract. And as you can see, we're not calling the init this time. This is for demonstration purposes. You can also call the init. So this would be possible both on the black box and the white box. But this is not possible on the black box because setInitial, let's look at the code. SetInitial is actually not a public function. This function is not visible. When it gets compiled, this name disappears. So this does not get converted into an actual constructor. And the same perform add here is not an endpoint, is not public. You will not be able to call it on the blockchain, but you will be able to call it in the whitebox test. So you see a whitebox deploy here, like this. For the query, it'll go the same way. And for the call, here we call the perform add. We would not have been able to do this on the black box test. So this is the whitebox test. It's very useful when you want to go under the hood, when you want to test a very specific function in your smart contract that is not public. And you can mix and match and merge like whitebox calls with black box calls. You can do them in any way you want. Do be warned though, it is possible, it's still possible to leave a trace. So there's no restriction on that. But the whitebox calls will not leave a trace because they are not real transactions. And it is not possible to have a trace for them because, again, they're not real transactions. And you couldn't be able to replay this on a black box system or on an actual blockchain. So we went through black box and white box. And both of these are actually integration tests. So we could have grouped them under the umbrella term integration test because they're usually bigger, they involve more transactions. But sometimes you just want a really short unit test, right? Let me show you a short unit test. And we have a unit test right here. It's called workshop test. This is a unit test. This unit test does not do any transactions. It does not initialize in any way a blockchain or anything. It just creates an instance of a contract object. Now, contract objects need a backend, need some sort of support system for their types. And we have a few options here. There's a debug API, there's a static API, which is the most minimal. And oftentimes for unit tests, we use this single takes API. This is like a global static transaction. We can configure it, but we usually don't configure it too much. So this is ideal for short tests where we don't care very much about the context. We just want maybe to see a pure function or very simple function being executed. And in this case, we're calling init, we're calling add, and we just want in the end to check that the addition works properly. So again, there's no gas, there's no sender, there's no receiver, there's no money, there's no nothing, just throwing out a few functions from our contract. So we also have this unit test. So with this being said, we went through all the kinds of tests that we can write in Rust, right? So we can write the scenario tests in JSON, but that is it's a tedious task to do by hand. It's not worth it. So we prefer to do it in Rust. So either a black box test, that would be the closest to reality, a white box test if we want to go a bit deeper, and unit tests, those are always welcome for our functions. And now let's see how we integrate this into the CI. Again, I'm not going to go into great detail with this. But in principle, what we want to have is a .github folder with some workflows and action.yaml. And you just want to import this thing here. Contracts.yaml, that's built by us, and it will give you all these cool actions that will test your code on every pull request, right? Now I have to make a little comment here. Let me just pull up the code once again. There's two ways of running the code, again, with the two backends. The Go backend, so only these tests actually run the Go backend, and all the other ones only run the Rust backend. Now, the Go backend, unlike the Rust backend, actually needs the contracts to be compiled, because otherwise it cannot run them. This is usually a slow task, and we wanted that whenever you write a cargo test, we wanted the developer to have the test run really quickly. We didn't want them to have to compile all the smart contracts every time. So by default, when you run cargo test, these tests will not actually run. They will be ignored. But when you run them in CI, the CI will run them too. There is actually a way to run them too locally, but this is out of scope of this video. You will find it in documentation in the next few days. So this concludes our testing and our CI. And the final point I wanted to make, I wanted to conclude everything with a nice diagram. So everything I've talked about until now in a single visual diagram. Drum roll, please. This is the diagram. So this is our testing system. You've already seen everything that's on this diagram in action. So you've seen the interactor first, and you've seen the interactor do some real transactions on the blockchain. And you've also seen the interactor produce a trace. You've also seen a manually implemented JSON scenario, and then you've seen a black box test that ran on the Rust VM debugger, and this black box test also created a trace for us. You've seen a white box test, but in this case, the trace is only partial because you cannot get a trace for the white box transactions. Those are not real transactions. But if you want to mix a white box functionality with black box functionality, you can still get a trace for the black box transactions. And then we took these JSON scenarios and we made the Rust tests out of them. The Go tests then we sent to the Go VM, to the testing tool that's part of the VM to run, and then the Rust tests we sent to the Rust VM debugger. So as you can see here, there are 3 ways to run Rust tests in the debugger, and there's one way to run Go tests using the Go backend right now, and one way to run the same transactions on the blockchain. And they're all connected, they're all interconnected with this scenario format that defines how we think about contracts and their execution. This concludes my presentation here about testing. There will be more information on the documentation website. So with that being said, I wish you happy coding. I wish you as few bugs as possible, and I wish you successful launches and happy customers. See you soon.